Algebra I 11.1e, proof of contradiction, also known as indirect proof. In an indirect proof, we assume the opposite of what we're trying to prove is true. Then we show how our assumption leads us to a contradiction. Since it leads to a contradiction, our assumption must be false, and what we really want to prove must be true. Does that sound confusing? So here's a real easy example. Let's say I want to prove that my neighbor has a cat. So what I'm going to do is I'm going to try to prove they have a dog instead. So I really am trying to prove that they have a cat. So I need to do anything I can to prove they have a dog, so I can prove myself wrong. When I only see cat food in their shelves and a litter box in the corner, my dog assumption is contradicted, isn't it? I don't see any signs of any dog toys. I don't see a dog collar. I don't see a leash. All I see is cat food and a litter box. So my dog assumption is false. And I've proven that they have a cat instead. See? So what you do is you try to prove the opposite, and when you prove that it's wrong, then you know that what you were trying to prove in the first place is true. All right? Does that sound crazy? All right, so we're going to show that the square root of 7 is not a rational number. We're going to show that it's irrational. And we're going to do this by using an indirect proof or a proof by contradiction. So what we're going to do is we're going to prove that it's rational and then find out that it's wrong. Okay? So if p is a prime factor of a squared, then p is a factor of a. So we'll assume that the square root of 7 is a rational number. And we write in its simplest form as a fraction. Rational number would be a over b, wouldn't it? As long as b is not 0. And since we said it's in its simplest form, we know that a and b have no common factors greater than a 1. It's simplified. It's in its simplest form. Okay? So the square root of 7 would then be equal to a over b if we're assuming it's a rational number. We're assuming the opposite of what we're really trying to prove. So we're trying to prove it's irrational, so we're going to prove that it's rational. All right? And rational numbers are a over b, and that's in its simplest form. Now, as we mentioned in a previous video, when you want to remove the radical symbol, the square root sign symbol, you can take it off and put a power of 2 on the other side. So squaring both sides, we can remove that radical sign. Now we've got a squared over b squared. Now, multiplying both sides by the reciprocal of the denominator. So the denominator is b squared. So we're going to multiply both sides by b squared over 1. And this b squared cancels out this b squared, doesn't it? So we just end up with a squared over 1, or a squared. And on this side, b squared over 1 times 7 over 1 gives us 7b squared. So now our equation shows that 7b squared equals a squared. And it shows that 7 is a factor of a squared. See? Because it says they're equal. Well, since 7 is a prime number, it also must be a factor of a by itself, not squared. So a equals 7x. So we're going to say x is just some integer. I could have put any letter there, okay? So now a is equal to 7x. So we can say 7x squared is equal to 7b squared, okay? So remember, because 7 is a prime number, it also must be a factor of a, all right? And we're just letting x be some integer x, all right? So now we've got 7b squared equals 7x squared, and substituting the 7x for the a, okay? See? Because a equals 7x. So now we do 7 squared, that's 49x squared, see? When we raise a product to a power. So now we got 7b squared is equal to 49x squared. Well, multiplying both sides by the reciprocal of 7, which would be 7 over 1, the reciprocal would be 1/7, wouldn't it? That gives us 7 over 7b squared, which is really a 1. That's identity property, isn't it? So now we just have b squared on this side. And on this side, we get 49 over 7, which simplifies to just 7, because 7 times 7 is 49. So now we've got b squared equals 7x squared. See that? And this shows that 7 is a factor of b squared, which means it's a factor of b. Well, we said that it was a factor of a squared, so it was a factor of a. Well, this means a and b have 7 as a common factor. By doing this, we showed that it had that 7 was a factor of a, and it turned out that 7 was a factor of b. But we said before it was in a simpler form, and it had no greater common factor than 1. A over b was in its simplest form, remember? So how could 7 be a factor? Well, this contradiction shows our assumption that 7, the square root of 7, is a rational number, is false, because it was only supposed to have the common factor of 1, and we just did this and showed that it had a common factor of 7. So we proved ourselves wrong. And because of that, that means the square root of 7 is irrational. We couldn't prove it was rational, so it must be irrational. See that? It's like if you're trying to prove that your friend only has sisters, and to prove your friend only has sisters, you're going to prove she has brothers instead. And when you try to prove she has brothers, everything comes out false. So that means she must have sisters. See? So our next video, 11.2a, is going to be non-negative radicands. Remember, radicands are the number that are inside the radical symbol. That 7 is a radican. All right? And a non-negative one means it's positive, doesn't it? If you want to have a link to any of the previous videos we did, these will all help you. If you want to get an A in algebra, keep watching these if you've skipped any, okay? If you've missed any or you've forgotten them, watch these. They're all in the description of this video. And for Algebra 1, I've been putting all the previous videos in the description of the video, okay? And that way, if you're on Christmas break or you're on some type of weekend and you've forgotten what happened at the beginning of the week, you can go and re-watch these to get a review so that you can move forward and know what you're doing, and then you'll get an A, all right? Okay, we're going to move on and talk about non-negative radicands, and I hope you're doing all right, and I'll see you next video. Bye.